Okay, hello guys, and welcome back to another version for microcontroller implementations and software. Today we'll be looking at our same thing, our ARM processors, another one in our ARM series that we're doing, and we're going to be programming the ARM now. This is kind of an add-on to our last little feature that we had that was on the Blink project, blinking one of the LEDs that's on the STM32F0 Discovery board by ST Microelectronics. What we'll be doing is going ahead and programming this guy using the ST-Link utility. Apologies, I still haven't had time to sit down and get the ST-Link to work with Kyle here, with the IDE that I'm using, this Microvision or whatever, Kyle. So I apologize for that. Once I figure that out, I will probably make another movie like this that shows you how to use up here. See the load and how to set that up. It's in the properties and you got to set it all up and everything. I just haven't done it yet. Anyway, we have our code, so I'm going to go ahead and build it real quick, make sure that everything works properly. It should build us our executable. What we're going to do is, in our folder structure that we have, I'm going to see if I can't pull that up. Here we go. Okay. Alright, so in our folder structure you get all these files that it outputs, and we're looking for the hex file. So there's our new Blink hex file that we have produced by building, and of course we've got 0 arrows, 0 warnings. So now we're going to pull in our ST-Link utility software. Again, I'll probably put the link to this in our in the description of this movie, but you can go to ST's website and download this little software. And basically, it kind of reminds me of the if you watch my Pick Microcontroller videos, it reminds me of the ME Labs U2 programmer. Basically, it's very simple. It has just a software that's just for programming, and that's exactly what this is. It's not debugging or anything like that. It's just literally for flashing, and that's what is used for the ST-Link hardware that comes with the STM32F0 Discovery board. That is the one that we're working with, and so this is the software that goes along with it for programming your chip, which is the STM32F051R8, I believe, chip. That is the one that we are using. That comes equipped on the Discovery board. And then I want to point out again, for those of you who may not have seen my earlier videos, but I want to point out again that the cool thing about this little Discovery board is the fact that you have this ST-Link programmer, because you can actually remove the jumpers. There's some jumpers that are on there that, if you watch my other videos, I talk about it, but that you can remove, and then you can actually program external things. Like, let's say you build an entire embedded system, you can use this Discovery board, remove the jumpers, and it has a I can't remember what it is. I think it's a 6-pin header. Has a 6-pin header on it for all your data and clock and all the program data and whatever signals that come out of it. Kind of like when we did in-circuit programming on the microchip PICs. It's basically the same thing, and you can actually take those signals out of the board and use it as a programmer, as an actual programmer. So that's pretty cool, considering this thing is very, very, very affordable. It's under $10. Is this board, and I mean the ME Labs U2 programmer was, I think, over $100 for that programmer. So this is really cool. You get a programmer for ARM systems, ARM processors, that's, you know, under $10. You can't beat that. So highly recommend this little dev kit. Well, anyway, we're going to go ahead and find our file. So go File, Open, I suppose. Get into our ARM. And into our folder, I just put it in this new folder, and there's our new Blink hex file. Double click on that. Now it is loaded in. Like, again, it looks a lot similar to the ME Labs deal. It shows you some, shows you the disassembly code, the ASCII, you know, kind of like disassembly and all of that. Shows you all the stuff. Shows your data width and everything that's going on. Basically, that's pretty much all you got to do, is just open that up in there, and then what we will do is we will connect our target and we will program this. I'm going to stop the camera here for my screen capture, And what I'm going to do is I will then go to video, and then I'll try to combine the two videos. Hopefully that all works out. So I'm going to pause here, and we'll be back with the actual physical programming of it. Thanks.
Okay, hello guys, we're back with the actual physical video. Now, this is the first time I've actually had to hold the camera with one hand and do stuff with my other hand, so you guys will just kind of have to bear with me here. This is the little board. This top half here is the actual programmer. That's this part from basically this up is the programmer, the actual programmer. These are the jumpers I was talking about that you can remove, and then this is the 6-pin header that you can then connect a ribbon cable or something to, and then program external ARM processors with. It's pretty dang cool. Also, then here's the actual processors that we're playing with, the actual demo processor. Here's your two buttons that they give you a reset button, and they give you a user button to program to do whatever you want. And what we're looking at is trying to do this through the camera is interesting. I believe it's this LED right here. If you can see that LED 3, I don't know if you can see that, but that's I believe the one. It's either that one or oh no, it's this one. It's this PC8, because I remember that from the code. It's PC8 that we're playing with, so it's this LED. Excuse me, not that one. It's this one. So this LED should be the one that'll be blinking when we get it all together. So let's see if we can't do this. See how far I can scoot this across the table while attempting to plug it in. Okay. Oh, come on. There we go. It's plugged in. So it's got some previous software on it. But anyway, I'm going to blank it real quick. Here we go. Let's see if I can't get this to work. Oh, come on. I think I have to restart the software, because you have to have it plugged in and then open the software, I believe. Oh no, mine had to install. Can you see that? See where I had dongle. Device driver installed successfully. So hooray, you have to let it install. I forgot about that. So you have to let it do its thing, let Windows do its thing by recognizing it and installing and all that fun jazz. I forgot about that. And then once it gets installed and it becomes, you know, able to be used, then you can actually control it, I believe. So okay, so I just blanked it. So now there's no code running on it whatsoever. So that's why the LED stopped. Okay. We've got our power LED, actually power LED, and our communication LED. That's the one that's kind of blinking right now, is the communication, the USB communication. Okay, now I'm going to try this. I know I apologize, but I always hate when people take video of their screens, but you know, there's kind of no other way to do this. And I could try and do a picture-in-picture thing, but it just doesn't really come out right. So what I'm going to do is I'm going to try to zoom in really close where you guys can see it. Now, I clicked on full chip erase to blanket, and that's what I did. And as you can see, I don't know if hopefully this is picking this up, it's all F's everywhere, which means it's completely blank. It's completely erased. So now I am going to choose our open. I'm going to choose our new blink. I can do this. I'm using a mouse with my left hand, and I'm right-handed, so it's interesting. Okay, so now the device has been detected and everything. See, it's showing that it's F05 and all device ID and all that fun stuff. So everything's set up to go. All we have to do is program it. I can't remember, it's been a while. There we go. Program verify. No. Let's see. Yeah, I think, yeah, program and verify. So we click on that. We get this screen that says it's going. It's going to start whenever we hit go. There's our path for our image, and we're going to hit go. And then it goes away. All should be good, and guess what? I have over here my blinking light. Hooray! So my LED is blinking. I haven't coded the button, so the button doesn't do anything. Reset. See, reset holds it and reset, and then clear. So same thing as like pulling the mem clear line. They have the reset hooked up. If you watch my first video in this, you'll get I show the schematic off, and you can see how this resets hooked up. but it's basically like yanking the mem clear line. It does a software reset when you push it. And that's pretty much it, guys. Got our little blinky deal to work. I could play with it. I could play with it, except using my left hand when I'm right-handed doesn't work very well on the mouse. But otherwise, I would play with it and show you how you can change the timing and get it to blink faster or slower, or kind of whatever you want to do. But that's pretty much all there is to it. It's really simple. Connect it up, let Windows install its drivers and everything, then pull up your ST-Link utility and open up your software, your hex file or whatever that's in it, and go from there. Oh, and just as a side note, remember to choose in Kyle or Microvision to have it export a hex file if you're going to use the ST-Link utility software. Make sure it exports that. Not in the previous video to this one, the software portion of this Blink project I'm doing with the ARM, I tell you how to do that, how to actually do that. So check that video out if you don't know how to get Kyle or whatever it is to output in a hex file. Just look at that video and I tell you how to do that. So anyway, there it is, folks. Hope you enjoyed it. Talk to you later.